The heavy fighter sat on the German airfield like a challenge to everything they believed about aviation engineering. Its massive radial engine dominated the front end. The fuselage wrapped around it thick as a barrel. Landing gear spread wide and robust beneath the wings. German pilots walking past shook their heads. They called it the flying milk bottle. Some laughed at its ungainly appearance. Others muttered about American crudeness. But one man approached with different eyes. Eyes trained by years of testing aircraft from every nation. Eyes that had learned not to trust first impressions. That afternoon in November 1943 would shatter assumptions about engineering philosophy. Within 90 minutes, everything would change, at least for one German who understood what he was seeing. The captured Republic P-47 Thunderbolt had arrived 2 weeks earlier. Its American pilot had made a costly navigation error. Lieutenant William Roach thought he was landing in England. Instead, German soldiers surrounded his aircraft at a Luftwaffe base. His mistake became Germany's opportunity. The massive fighter was quickly moved inland to Rechlin, away from prowling Allied fighters that would strafe anything valuable. Now it waited for evaluation. Painted in German camouflage colors, marked with Luftwaffe codes, ready to reveal its secrets. Hauptmann Hans Werner Lärscher had been flying since childhood in the 1930s. Born in Breslau in 1916, he started with gliders. Worked his way up through determination despite his family's limited resources. When Hitler's secret rearmament began, opportunities opened. By 1939, he was testing aircraft at Rechlin, Germany's primary flight test facility. Unlike combat pilots who specialized in one or two types, Lärscher flew everything. New German prototypes, production aircraft, captured enemy planes. His logbook would eventually record over 120 different aircraft types. He was also a trained aeronautical engineer. His reports were known for brutal technical honesty. When an aircraft was inadequate, he documented it. When an enemy design was superior, he said so. This honesty had created enemies among Nazi officials. They preferred optimistic assessments to accurate ones, but his expertise was too valuable to dismiss. When Hans Werner Lärscher evaluated an aircraft, people listened, even when they didn't like his conclusions. The intelligence briefings had been clear. American aircraft were crude machines, mass-produced by a nation better at making refrigerators than fighters. The P-47 supposedly proved this point perfectly. Heavy, unsophisticated, relying on brute force rather than elegant engineering. German fighters like the Messerschmitt Bf 109 and Focke-Wulf 190 were precision instruments. The P-47 was supposedly a sledgehammer. Lärscher was about to discover something that would challenge this comfortable belief. The Americans hadn't built a crude aircraft. They had built something far more dangerous, something practical, something designed not for aces but for armies, not for breaking records but for breaking enemies through overwhelming numbers and relentless availability. The difference between individual excellence and industrial warfare, between building for peak performance and building for sustained operations. It was a distinction that would prove decisive. Standing before the massive fighter, Lärscher began his inspection. The construction quality was immediately apparent. Clean welds throughout the airframe, precise panel gaps despite mass production, high-grade materials in every component. This wasn't crude manufacturing. This was sophisticated mass production. There was a profound difference between the two concepts. The aircraft had been built to tolerances that German factories were struggling to maintain, increasingly stretched thin by the war's demands. Quality control suffering as experienced workers were drafted, replaced by forced labor with minimal training. Lärscher climbed into the cockpit and immediately understood German pilot complaints. The space was enormous, absolutely huge compared to the cramped confines of a Bf 109. A German pilot accustomed to his aircraft fitting like a tight glove would feel lost. But as Lärscher settled into the seat, realization dawned. This wasn't a flaw in the design. This was deliberate engineering philosophy. In a Bf-109, he had to crouch constantly, avoiding banging his head on the low canopy. The cockpit was so tight that reaching instruments required effort. Long missions became physically exhausting ordeals. German engineering prioritized performance above all else. If pilot comfort suffered, that was acceptable. The price of peak capability. The P-47 cockpit was genuinely comfortable. Not just adequate, but pleasant to occupy. The seat was well padded and adjustable. Room to move and stretch during long flights. The canopy was high and clear, providing excellent visibility in all directions. Everything was within easy reach. No straining required for any control or instrument. This was human factors engineering, something German designers rarely considered. The instrument panel revealed another surprise: color coding throughout the displays. Red and green sections marked acceptable operating ranges. A pilot could monitor engine status at a glance, without reading actual numerical values. Intelligence reports mentioned American fighter units including pilots from multiple countries, Free French aviators, Polish pilots, some who barely spoke English. The color coding made sense now. Green meant good operation. Red meant danger or problems, universal concepts that transcended language barriers. A pilot who couldn't read English could still operate safely. Brilliant design philosophy, not from pure engineering excellence, but from inclusive operational thinking. German instruments required precise understanding of specifications and limits, numbers that had to be memorized and monitored constantly. The P-47 was designed for pilots with minimal training, who could operate it safely without extensive education. This wasn't crude engineering. This was practical engineering that acknowledged human limitations. Control layout was logical and well-organized throughout. Throttle, mixture, and propeller pitch grouped together on the left side. Fuel system controls clearly labeled and positioned. Everything designed for intuitive operation. German fighters were built for expert pilots. The Bf-109 was notoriously difficult on takeoff and landing. Narrow landing gear made ground loops common accidents. It took considerable skill to master safely. The Luftwaffe had accepted this because their training program produced skilled aviators. Elaborate instruction that created experts from novices. But by late 1943, that training was collapsing. Fuel shortages meant new pilots received minimal flight time, thrown into combat with inadequate preparation. Germany needed aircraft that novice pilots could fly safely, but they were still building fighters for aces, for experts who no longer existed in sufficient numbers. Lärscher went through the pre-flight checklist carefully. The manual was comprehensive and clear. Step-by-step procedures explained in detail. German manuals assumed pilot expertise and experience. American manuals assumed pilot ignorance and explained everything thoroughly. He started the massive Pratt Whitney R-2800 engine. It roared to life with distinctive sound and power. Then something struck him immediately, a recurring theme that would dominate his evaluation. The engine ran smoothly, beautifully, consistently smooth operation. He'd flown enough American aircraft to recognize this pattern. Their engines were reliably smooth and consistent. German engines, particularly late in the war, were increasingly temperamental. Manufacturing quality varied between different factories. Replacement parts didn't always fit properly together. Engines that ran perfectly when new developed problems quickly. The R-2800 idled like it could run forever. No vibration or rough spots, no concerning sounds or irregular operation. Just smooth, powerful, reliable performance. This represented mass production at levels Germany couldn't match anymore. Building one perfect engine in a laboratory was achievable. Building thousands of consistently reliable engines was something else entirely. After receiving clearance, he taxied toward the runway. Another revelation emerged immediately. The P-47's landing gear was broad and extremely robust, the tailwheel locked securely into position, keeping the aircraft tracking straight and stable. Taxiing was easy and straightforward. Visibility over the nose was good. The aircraft felt stable and predictable. In a Bf-109, ground handling was a constant challenge and concern. Narrow landing gear made the aircraft inherently unstable on the ground. Visibility over the long nose was poor during taxi. Inexperienced pilots frequently ground-looped during taxi or landing, damaging aircraft even without enemy action. The Luftwaffe accepted these characteristics as the price of high performance. Temperamental handling was the cost of peak capability. The P-47 was designed for operation from rough forward airfields by pilots of varying skill levels and experience. The robust landing gear could absorb hard landings without damage. Good ground handling characteristics meant fewer operational accidents. In his memoir, Lärscher would later write about forgetting to lock the tailwheel, nearly ground looping but catching it in time. The fact that he could recover, that the aircraft was forgiving enough to save, would have been impossible in a Bf-109. German fighters were unforgiving of pilot errors. Lined up on the runway, Lärscher advanced the throttle smoothly. Acceleration was genuinely impressive despite the aircraft's weight. The massive engine pushed the heavy fighter forward with authority. The takeoff run was longer than German fighters, but not excessively so given the weight difference. The aircraft lifted off smoothly and predictably. Landing gear retracted without problems. All systems functioned exactly as designed. Climbing to altitude for performance testing. The P-47 was not agile in the German sense of fighter design. It didn't turn tightly like a Bf-109, didn't have the instantaneous response of German fighters, but it was stable, predictable, and solid in all flight regimes. Lärscher experimented with various flight configurations. The hydraulic system worked smoothly throughout all tests. Everything functioned as intended without problems. There were no quirks or unexpected behaviors, no systems that required careful management or special techniques. This was the pattern emerging clearly. The P-47 wasn't the most agile fighter aircraft. It wasn't the fastest at low altitudes, didn't excel in traditional dogfighting scenarios. But it was competent in all operational areas, reliable in all systems and components, forgiving of pilot errors and inexperience. German fighters were temperamental thoroughbreds requiring expert handling. The P-47 was a workhorse designed for sustained operations. In industrial warfare, workhorses win campaigns. Individual excellence wins battles but loses wars. At altitude, the P-47's turbo-supercharger came into its element. Above 15,000 feet, performance was outstanding. The aircraft accelerated smoothly and maintained power, where German fighters were struggling in thin air. Dive performance was particularly impressive. Roll rate was excellent for such a large aircraft. Lärscher flew for about 90 minutes total, putting the Thunderbolt through comprehensive evaluation. The aircraft never surprised him negatively during any maneuver. Everything worked as it should consistently. The engine never faltered or showed problems. Controls remained responsive throughout all tests. Systems remained functional under all conditions. That was when deeper understanding dawned. The P-47 wasn't designed to be the ultimate fighter in combat. It was designed to be the ultimate operational fighter. There was a profound difference between these concepts. German engineers designed for peak performance under ideal conditions. American engineers designed for sustained operations under real conditions. A Bf-109 in perfect condition flown by an expert pilot might outperform a P-47 in dogfighting. But how often was a German fighter in perfect condition anymore? How often were pilots truly expert nowadays? How often could mechanics perform precise maintenance required? Under field conditions with limited resources and constant pressure, the P-47 was designed assuming maintenance would be performed by mechanics of varying skill, using parts from different production batches. Under field conditions, possibly under enemy fire. It was designed assuming pilots might be tired, stressed, wounded, or inadequately trained. Designed assuming aircraft would take battle damage and need to continue flying. Every design decision made perfect sense once this philosophy was understood. Robust construction for battle damage survival, forgiving handling for stressed pilots. Intuitive controls for quick training, reliable engines for consistent availability. All served operational sustainability rather than peak performance. The difference between fighting one battle and fighting a war. Returning to Rechlin, the landing was completely straightforward. Robust landing gear absorbed touchdown smoothly. He taxied back to the hangar area and shut down. Ground crew members gathered around eagerly. What did he think of the grotesque American fighter? His assessment would surprise them completely. Climbing out, he stood looking at the aircraft, considering his words carefully. "It's the best designed operational fighter I've ever flown," he told them. The mechanics looked confused and skeptical. Best designed? It was huge, heavy, inelegant in appearance. How could it be well designed? "It's not designed for performance," Lärscher explained patiently. "It's designed for operations, and there's a fundamental difference between those goals." That evening, he sat at his desk beginning his technical report. This was always the most critical part. Flying the aircraft was one thing. Understanding strategic implications was another entirely. He organized his report into clear sections: performance characteristics, handling qualities, systems evaluation, strategic assessment of design philosophy. In the performance section, he documented facts objectively and thoroughly. The P-47 was fast at high altitude, slower at low altitude compared to German types. Dive performance was genuinely excellent. Turning performance was adequate but not exceptional compared to lighter fighters. Rate of climb was good but not outstanding. High-altitude performance was superior due to turbo-supercharger technology. In the handling section, he noted stable, predictable characteristics throughout. Easy ground handling for all pilot skill levels. Forgiving flight behavior that reduced accidents. Good visibility from the spacious cockpit. Comfortable seating for long-duration missions without fatigue. In the systems section, he detailed color-coded instruments for intuitive operation. Logical control layout that reduced training time. Robust construction that survived battle damage. Smooth, reliable engine operation under all conditions. But the strategic assessment section contained his most important observations. Observations that would later prove prophetic, even though his report would be filed and ignored by higher command. The P-47 Thunderbolt represents a fundamentally different design philosophy from German fighters, he wrote carefully. German aircraft are optimized for peak performance and assume expert pilots and maintenance capabilities. The P-47 is optimized for operational reliability and assumes average pilots and field maintenance conditions. This aircraft is designed to be operated in large numbers by pilots of varying skill levels throughout. The forgiving handling characteristics mean fewer training accidents. The robust construction means more aircraft return from combat missions. The reliable engine means higher availability and less maintenance downtime. The intuitive controls mean faster pilot training and conversion. Most significantly, every design decision prioritizes sustained operations over peak performance capabilities. He paused, considering how to phrase his conclusion. It would be controversial and possibly dangerous, but accuracy mattered more than political comfort or convenience. Assessment. The P-47 is not crude engineering as intelligence briefings suggest. It is sophisticated operational engineering designed for industrial warfare. Germany builds fighters for individual excellence and peak performance. America builds fighters for sustained industrial war. If the Americans can field hundreds of these aircraft flown by adequately trained pilots, our numerical and qualitative advantages will be negated through superior operational availability over time. Recommendation: German fighter design philosophy must incorporate operational reliability as the primary requirement, not a secondary consideration. We cannot win an attrition war against an enemy that can keep more aircraft operational more consistently. He signed the report and submitted it through proper channels. Knowing it would be read, discussed, and ultimately dismissed as overly pessimistic thinking, the P-47 was still considered a crude American design. German fighters were inherently superior through engineering excellence. End of discussion among leadership. No debate allowed, but Lärscher's predictions began manifesting almost immediately. By early 1944, P-47 Thunderbolts appeared over Germany in massive formations. They escorted American bomber streams deep into the Reich territory, and they kept coming relentlessly, day after day, mission after mission without pause. German fighters intercepted them and sometimes achieved victories, shot down individual aircraft in combat, but the next day brought more P-47s, always more replacing losses. The supply seemed absolutely endless and inexhaustible. Luftwaffe pilots reported growing frustration with the situation. They damaged P-47s that should have been destroyed, only to watch them fly home successfully. They would shoot down American pilots one day, then encounter different American pilots in new P-47s the next day. The supply pipeline never seemed too empty. Meanwhile, German fighter production struggled with increasing problems. Allied bombing disrupted factories and supply chains. Material shortages forced design compromises and substitutions. Quality control suffered as experienced workers were drafted, replaced by forced laborers with minimal training or motivation. Aircraft that should have been reliable developed problems quickly. Engines failed prematurely due to manufacturing defects. Systems malfunctioned from poor quality components. The operational availability gap widened steadily and relentlessly. The Luftwaffe might have more aircraft on paper, but fewer were actually flying on any given day. American units maintained higher operational readiness rates because their aircraft were specifically designed for sustained availability. Lärscher continued his work at Rechlin flight testing, flying more captured aircraft and writing detailed reports. He flew a captured P-51 Mustang and was impressed by its combination of range and performance capabilities. He flew Spitfires, Hurricanes, Soviet fighters of various types. Each evaluation reinforced the same fundamental conclusion. Allied aircraft prioritized operational reliability over peak performance. The P-47 Beetle that Lärscher had flown eventually went to Circus Rosarius, a special Luftwaffe demonstration unit that traveled to frontline bases, showing German pilots what they were facing, how to fight Allied aircraft most effectively. Ironically, this meant German pilots received extensive briefings about the strengths and weaknesses of the P-47 design, but their own aircraft weren't being redesigned to match its operational advantages and philosophy. The war continued grinding forward relentlessly. By late 1944, the Luftwaffe was in complete collapse, not because German pilots lacked courage or skill, but because the industrial base couldn't sustain operations anymore. Aircraft sat grounded for lack of fuel. New pilots received minimal training because fuel wasn't available. Replacement parts became increasingly scarce and difficult to obtain. Everything that Lärscher had identified as the American advantage, operational sustainability over peak performance, was completely absent from the German war effort. Hans Werner Lärscher survived the war through careful flying. His skill as a test pilot meant he never crashed, never seriously damaged an aircraft throughout his entire career. An extraordinary record given his experience. He had flown over 120 different aircraft types, many of them captured enemy aircraft, without manuals or prior familiarization with systems, relying on engineering knowledge and flying skill. After Germany's surrender, Allied technical intelligence officers interrogated him. They were fascinated by his experiences flying captured aircraft. They found his reports in German files, asked about his assessments and conclusions. "You concluded that American aircraft were superior not in performance, but in operational design," an American officer observed. "That's an unusual assessment from a German pilot." Lärscher nodded thoughtfully. "It was the most important assessment I could make. Your pilots weren't necessarily better than ours individually. Your aircraft weren't necessarily faster or more maneuverable in combat. But you could keep more aircraft flying more consistently. You could train more pilots faster. You could sustain operations that we couldn't sustain long-term." "Was this apparent when you flew the P-47?" the officer asked. "Immediately obvious," Lärscher replied. "Every design decision made sense once I understood the philosophy behind it. You weren't building for dogfighting supremacy or peak performance. You were building for sustained operations under real conditions. The comfortable cockpit meant pilots could fly 8-hour missions. The forgiving handling meant fewer training accidents. The reliable engine meant less maintenance downtime. The robust construction meant battle-damaged aircraft returned home. Everything served operational availability rather than peak capability." "Did German leadership understand this distinction?" another officer inquired. Lärscher laughed bitterly. "My report was filed and forgotten. The assessment was that I'd been demoralized by flying enemy aircraft and had lost objectivity." German engineering was superior by definition. American engineering was crude by assumption. That was the official position. Any evidence to the contrary was dismissed automatically. If Germany had adopted American design philosophy, would it have made a difference in the war's outcome? Lärscher considered the question carefully before responding. By 1943, probably not significantly. Germany's industrial base couldn't match American or Soviet production. Regardless of design philosophy or approach, but if we had prioritized operational reliability from the beginning, our fighters would have been more effective throughout the entire war. We lost many aircraft to accidents, mechanical failures and maintenance issues that better design could have prevented. The interrogation revealed a disturbing pattern throughout German engineering. Lärscher wasn't the only engineer who had recognized Allied advantages. Many had written similar reports. Many had made comparable recommendations. All had been ignored systematically because the conclusions contradicted Nazi ideology about inherent German superiority in all fields. Evidence didn't matter when it challenged comfortable beliefs. The final production numbers told the complete story. The United States produced over 15,647 Thunderbolts during the war. At peak production, one complete Thunderbolt rolled off assembly lines every hour. Germany produced about 36,000 single-engine fighters total, across all types during the entire war. And German production was constantly disrupted by bombing, material shortages, and labor problems. More importantly, American aircraft maintained higher operational readiness rates consistently. A unit with 100 P-47s might have 85 or 90 available for operations on any given day. A German unit with 100 fighters might have 60 or 70 available, with the rest grounded for maintenance, lack of parts, or fuel shortages. The multiplication effect was devastating over time. More aircraft produced times higher availability rates. Times better sustainability equaled overwhelming numerical superiority at the point of actual contact with the enemy. In his later years, Lärscher wrote his memoir, Luftwaffe Test Pilot, Flying Captured Allied Aircraft of World War II. The book provided detailed accounts of his experiences flying everything from B-17 bombers to P-51 fighters. His assessment of the P-47 included detailed technical observations, and his famous comparison of the comfortable American cockpit to the cramped confines of the Bf-109. What makes Lärscher's story historically important isn't just that he flew captured aircraft. Many pilots on both sides did that. What makes it significant is that he understood what he was seeing. As a trained engineer and experienced test pilot, he could evaluate not just whether an aircraft was good or bad, but why it was designed that way, what that revealed about industrial philosophy and strategic thinking. The P-47 Beetle that Lärscher flew in November 1943 represented more than just one captured fighter aircraft. It represented a completely different approach to warfare itself. Germany approached World War II as if it were still World War I, where individual excellence and superior technology could win battles. America approached it as industrial warfare, where sustained operations and overwhelming numbers would win entire campaigns. German fighters were magnificent machines when they worked perfectly. The Bf-109 and Fw-190 were genuinely excellent aircraft designs, but, when they worked perfectly, became increasingly rare. As the war progressed and resources dwindled, manufacturing quality declined steadily, maintenance became increasingly difficult, spare parts became scarce commodities, fuel became unavailable for training or operations. The P-47, by contrast, kept flying reliably. It absorbed battle damage and returned home. Operated from rough forward airfields, could be maintained by mechanics of average skill, could be flown safely by pilots with minimal training, and there were always more of them available, replacing losses faster than losses occurred. This was the mathematics of industrial warfare that Germany never mastered. Lärscher had recognized this immediately during his evaluation flight. His report in November 1943 accurately predicted what would happen over the next 18 months of warfare, but his report was filed and forgotten because the truth was inconvenient. It contradicted comfortable beliefs about German superiority, about the inherent crudeness of American engineering. History is filled with moments like this, where obvious truth was ignored because it challenged established thinking. Hans Werner Lärscher flew the P-47 Thunderbolt once and immediately understood that it represented superior design philosophy, not superior performance in traditional metrics, but superior operations under real conditions. His reward was to be ignored, to watch his predictions come true, as the Luftwaffe was systematically ground down by an enemy that could simply keep more aircraft flying, more consistently and in greater numbers, day after day without pause or respite. The lesson remains timeless across all forms of conflict. In sustained warfare, reliability beats peak performance every time. Operational availability beats maximum capability consistently. Design philosophy matters more than individual excellence. The P-47 wasn't the best fighter of World War II in terms of speed, agility, or firepower, but it might have been the best designed fighter because it was designed not for air shows, not for test flights or record-breaking demonstrations. It was designed specifically for war itself, and in war, the side that can keep fighting longest usually emerges victorious regardless of individual battle outcomes. Industrial sustainability trumps tactical excellence when conflicts become prolonged attritional struggles. This was the truth that Hans Werner Lärscher discovered in 90 minutes of flying time over Germany, a truth that his superiors refused to acknowledge until it was far too late to matter.